Hello guys, this is Frankie, the product manager of the Ruijie switch and the router. Today I will give an introduction about our SOE solution. We will introduce from three parts. The first part is network connecting part, and the second part is the equipment part, and the third part is the networking management part. In the networking connection part, all optical switches will be connected by our optical fibers. And the optical fiber will be laid out from the ELV room to the classroom and office, one fiber, one room. And we will also release a specialized indoor access switch, SF2920, to connect it with the optical fiber. Many customers may want to know why we apply this design. Because when we communicate with many customers, they told us they have planning or they are building the smart campus right now. A large number of the smart terminal will be increased in the classroom and the office. The traditional way, they have to lay out the cable from the ELV room to the rooms. And this would result in the higher networking cost. So we hope to apply this design to achieve once deployment, long-term usage. And many customers may also want to know why we choose the optical fiber. There are three reasons. The first reason is that the higher bandwidth. The optical fiber can be up to 40 terabits. It can supply the sufficient bandwidth for the campus network. Another reason is that it is a longer life cycle. The life cycle of the optical fiber can be up to 30 years. And in some wet areas like Indonesia, IT teams told us the copper cable is easy to be crowded and cause some networking problem. So the optical fiber can figure out this problem because the optical fiber is not easy to be crowded because it is made by the plastic and the sand. Equipment part, in access layer, the installation position of the access switch is changed from the ELV room to the office room and the classroom. The indoor access switch brings three key values for our campus network. First value is the expansion port is more flexible. When we add new smart terminal in our classroom, we just need to connect the indoor access switch with our new added smart terminal. And we do not need to lay out the cable from the ELV room to the rooms. And the networking cost will be decreased a lot. In distribution layer, transparent distribution devices will replace the traditional distribution switch. In core layer, we will add a core combiner. Actually, the transparent distribution device and the core combiner are multiplexer and demultiplexer. 16 specific wavelengths information can be transmitted in one fiber between these two devices. And this change also borrowing some key values to our campus network. The first value is that is the maintenance free. Actually, these two devices are passive devices. So IT team do not need to do the configuration and the maintenance work for these two devices. And in this way, IT team only need to do the configuration work and maintenance work in access layer and the core layer. So the networking structure is simplified. And three-layer networking structure is changed to the two-layer. In next year, we will release a 3.0 SOE solution, and we will release the color optical box switch and the color optical line cards, which integrate the wavelength divergent multiplexing function based on the traditional Ethernet switch. And in other words, the color optical switch both have the WDM function and the traditional Ethernet function. In this way, in 3.0 SOE solution, we do not need the core combiner anymore, and the networking cost will decrease a lot. And in the distribution layer, we will also release the new transparent distribution devices in 3.0 SOE solution. And the new transparent distribution devices will apply the modular design. One transparent distribution card has 8 ports, can be connected with 8 access switches. And our customer can choose the suitable transparent distribution cards according to their requirement. In the networking management part, we will use the SDN controller, which can improve the efficiency of the operation and the maintenance work. And today, I will take you guys to have a live demo show about our INC, and we will offer 5 testing items in this live demo show. This is my partner Nick. He will help me to do the live demo show. And firstly, let me introduce the testing environment. And as you can see, this is our SDN controller, and this is our core switch 5760. And we also prepared 3 indoor access switch SF2920. One will be used for the zero-touch configuration, and another one will be used for the network access control. And the third one will be used for the zero-touch replacement. And we also prepared one laptop will be used for as a smart terminal to do the network access control testing item. When we build smart classroom, the most important step is device online. So firstly, we will introduce the zero-touch configuration and network access control in the first part. And when we meet the network problem, we only need 3 steps to solve this networking problem based on the SOE solution. The first step is checking fiber status, and we will show the faulty fiber detection. And the second step is checking device status, and we will show the loop detection testing item. And when we find the faulty devices, we will show the faulty device replacement testing item. The first testing item is zero-touch configuration. When building a new network, all access devices are put together, and the engineer will have to configure manually each access switch. These steps would waste a lot of human resources, and they may exist human error. Based on SDN controller, we only need to do the 3 steps to achieve zero-touch configuration. The first step is assigning initial IP segment. As we can see, the initial IP segment. And the second step is creating a template. As we can see, our SDN controller already have the default template with the default configuration. We just need to choose the basic protocol like Telnet and SNMP, and we also can do the networking planning in this template like assigning VLAN and related port. The third step is binding the template with the related switch. INC has 4 kinds of binding method. Today, we just need 1 device configuration, so we choose the single binding. And we need to add the serial number and the template we just created before, and the area name. Okay, we choose binding. Okay, Now we insert the fiber and the transceiver into the new switch. Okay, Nick, can you help me to insert the transceiver and fiber into the new switch? Now the interface can show the configuring process, and as we can see, the online status is ready to be configured, and then now the interface shows it is configuring. Okay, now as we can see, the online status shows that the online successful. So the configuration is complicated for this new switch. The second testing item is network access control. Right now, different type of smart terminal increase rapidly in campus, such as a computer, mobile phone, printer, smart screen, and smart blackboard. If these IoT terminals access the network without control, they may bore in the network virus and result in the campus network risk. In the conventional network environment, if they want to do the network access control, administrators have to manually collect the IoT terminal MAC address and bind them to the switch port, which is a complicated work for them. How to figure out this difficulty? We can use the terminal access control function in INC. We just need one click to achieve network access control. This laptop will be used as a smart terminal. Now it is already connected with our indoor access switch SF2920, and we can see the laptop screen. We already do the pin testing. Now it is not allowed to access the network. And we can see the INC interface. In the terminal management interface, we can see there is a terminal which is required to be approved. A type of the terminal IP address, MAC address, VLAN, and its port and the device serial number. All this device information can be shown in our INC interface. After confirming these terminal information with service department, with just one click for approval. And then now we give a confirmer for this terminal to access the network. Now we can see this smart terminal already connected with the network. You can see pin testing is successful. Okay. The third testing item is faulty link detection. When we meet a networking problem, it may be optical fiber problem. We can use INC to achieve optical link detection to solve this fiber problem. Now, we already put the optical fiber into the indoor access switch. As we can see in our screen, it is normal operation. And then we want to disconnect it. We want to simulate a disconnected status. We pull out the transceiver to simulate this status. And we do the link detection again. And now we can see it is detecting. This process may need 30 seconds. As we can see, these are the device model number and the link status optical model. And now we can see we already detected the disconnection status. And our INC also can provide the solving solution for this problem. The fourth testing item is loop detection. INC can also help us to check the device status, and we can do the loop detection in the INC. And my partner will insert the beginning and the end part of the cable into the indoor access switch to simulate the looping scenario. And we also can see in our INC interface, in the loop detection interface, we also have the alarm level, number of the part, device name, these device IP and this basic information about the devices, and these we will give alarm based on this information. Now we can see the loop alarm has shown in our INC interface, and if we want to know the detailed information about this alarm, we can find that this basic information like the looping port and looping devices, its serial number and IP and other basic information, and how to solve this problem. Okay. The fifth testing item is zero-touch replacement. When we meet the networking problem in the traditional network structure, we have to locate the fault area and locate the fault devices and replace the fault devices and then reconfigure them. It would waste a lot of human resources and time. So when we use our SOE solution, we only need to change the fault devices, and then the configuration will be automatically sent from our SDN server. So, if these devices is fault devices, my partner pull out the transceiver to simulate it is a false devices, and then we pull out the transceiver into the new devices, and the configuration will be sent to these new devices. And now we can see in our INC interface, and the INC interface shows the fault devices is the old series number, device name, and the device area, like this basic information. And then the new model, the new devices model, will be shown on this interface. Now we see the new devices information has shown on our INC interface. Its device serial number, device area, and its online status. Now we can see the new devices has been online. It's online success, and the replacement process is complicated. Okay, that's all for my introduction about this SOE solution, and I have introduced the networking connection part and the equipment part and the operation and maintenance part. Our SOE solution redefines the new networking structure for the green and sustainable networking structure for the smart campus.